To those that are new, welcome. To those that are coming back, welcome back to my YouTube channel. We are looking at multiplication and division, and please take note that in multiplication or division, when we have the same signs, the answer is always positive. That is whether it's multiplication or division. However, when we have different signs, it always gives you a negative answer. Same sign, always positive. Same signs, always positive. Different signs, always negative. So same sign, I just mean a negative times a negative, or a negative divided by a negative, and that is always going to be positive, whether it's negative and negative or positive and positive. Positive and positive, obviously positive. Then we have different sign. It's just going to be either a negative times a positive, or a negative divided by a positive, or the other way around. It always gives you a negative answer. As we look at the examples, we want to remind ourselves of that. Now, some people always get confused when they see two signs next to each other. That just means that sign times that sign, because they are next to each other. So you need to work out what sign will I have in the end. So please, as we look at the examples, we're going to look at a little bit more examples. However, pause the video, continue, try it, and then you come and continue to see if you are right. Okay, now before we get to looking at these examples, I forgot to write one important thing here as well. Take note that in multiplication, we are going to be multiplying the numbers and add the powers of the same base. You might want to write that down. Multiply the numbers. You can write it next to multiplication here on top in pencil. Multiply the numbers, meaning the coefficients, and add the powers of the same base. Now, to explain that in details, let's look at A. I just said you multiply the numbers, meaning you are going to do that. That's how we are multiplying the numbers, right? Then we add the powers of the same base, meaning we are going to take the base A, then we check what power was it here. When there's nothing, remember it's 1. So we are going to add the powers of A. So we are going to take this one and add that one. So that means the A is sorted because we are adding its powers. Then we move on to the next variable. We see that there's 1 here and it's also 1. So the next variable will be B. Then we take this one plus the other one. Then we go to the last variable, which is 3, and we see that there's 1 here. So we have a C to the power 1 plus 3. So that's basically what we are doing. Multiply the numbers, add the powers of the same base. So to continue this, multiplying the number, negative times a positive, different signs always come out negative, and 2 times 5 is 10. Then we come to A to the power of 3, because 1 plus 2 is 3, B to the power of 2, because 1 plus 1 is 2, and then we have C to the power of 4, because 1 plus 3 is 4, and we are done. Only add the powers of the same base. Moving on to B, we are applying the same theory. Multiply the numbers, so we are going to say negative 4 times 2 times negative 3. That's what we were told. Then we add the powers of the same base. Before we get to the powers, we want to remind ourselves of the fact that we said when the variable is not powered to anything, it's to the power 1. So that. Then we have what we are going to get is it's x to the power of 2 plus 1 plus 1. Remember, we are adding all the powers of the same variable. Then we move on. We have y, so we move on to y. We see that there's a 1 here, there's a 2, so we are going to say 1 plus 2. Then we see that there's no other variable, so we're just going to have those. So we simplify. Now, we can always look at it, because it's multiplication, we can always look at it like this. This negative times a positive will give me a negative. Negative what? Negative 8. What did I do? I just worked out this one times that one first. But I know I'm just doing this step by step because it's examples. However, when you get to understand things better, you're just going to do it once. Then I'm going to say this is negative 8 times negative 3, right? So that's basically what I have. X to the power of 2 plus 1 plus 1 is 4, and y to the power of 3. Now I have a negative times a negative, and that is supposed to come out positive because now we get 2. So we have a positive, and 8 times 3 is 24. So we have 24x to the power of 4, y to the power of 3. I do hope that you got the same answers, and if not, that you have figured out your mistakes. We move on to C. Brackets also means multiplication, so that shouldn't confuse us. However, we now have a minus there. It's separating these two things, so it's already giving you two terms. However, we need to be able to remove the brackets first. Try it first. Now to continue this, we see that when we have this, I'm going to write it out just so that, because it's the first example and you want to understand it. So I try to add some spice in it just to make it much more beautiful and much more interesting. So what you do is, because we have brackets, we want to make sure that when you have something outside the bracket, you are going to do that. So we're going to say m cubed times m squared. Then again, we will say m times negative 1. So m cubed times negative 1. So if we say if we are to do this, m cubed times m squared, then we know it's going to give us m to the power of 5. Remember, we add the powers, right? M to the power of 3 times negative 1 is just negative m to the power of 3. Now, we go to the next one. We have, remember, we said this is part of what comes after. So when we come and apply it, we should take it like this together and not as a single thing, not as m squared only. So negative m squared times m is like having this negative m squared times m. And that is, we multiply the numbers. Remember, coefficients is 1, 1. So negative 1 times 1 is negative 1. But we don't write it because we have an m. And 2 plus 1, because we add the powers, is m to the power of 3. Then the next one, we have a negative m squared times a negative 3. Because whatever we have outside the bracket should be multiplied with everything inside the bracket. So we want to make sure that we are applying that theory. So we have negative m squared times negative 3. It's just that I'm going to multiply the numbers, and the negative times a negative gives me a positive, and it's a positive 3m squared. You get that? So that is going to be simplified when we remove the brackets. However, we see that we are now mixing things, right? And that's the whole idea. We get to be taught about a certain specific topic. However, we end up combining things. So I gave you this example on purpose so that you can combine and go back to what I already explained. When you see this, you should already remember, I see minus, I see terms. I should know that there's 1, there's 1, there's 1. Just because, but I shouldn't write it in my own answer. I should just know that it's there. So m to the power 5, do I see m to the power 5? No. So it means I'm going to say m to the power 5 will stay m to the power 5. However, these are like terms, so it's negative 1 minus 1. And negative 1 minus 1 is negative 2m cubed. Remember, in addition subtraction, we are not touching the powers. We're just working the like terms. Then we have plus 3m squared. The only thing you could have done to this expression is factorize it. However, we're not looking at that yet. We are just working out, simplifying, so we cannot add unlike terms, so we are done, and that is C. Take note, when we have a power outside, it's for everything inside, and there's a difference between having a base and a power outside and just having a power. When it's only a power, we just bring the power and multiply it with each power inside. So we have here inside, we have a 1 and a 1 and a 1. So we need to make sure that we are able to do this, right? So when we do that, we are going to multiply 3 with those 1s. However, when it's 1, 1, we just bring the power that is outside and then come power everything inside with that power. So we are going to have a 3 to the power 3, x to the power 3, y to the power 3. It's just telling you that everything that is here is power to 3. So we have times negative 2x squared. Now we work out, we have 3 to the power 3 is 27. We want to make it easier for ourselves. Okay, then we see that, okay, now we can now go back to multiplying the numbers, adding the powers of the same base. 27 times a positive times a negative is a negative, and 27 times 2 is 54. So we have a negative 54. X to the power of 5 because we add the powers, y to the power of 3 because there's no y there, so we're just going to keep that power. And so we are going to look at some examples on division. And now we come to this one. Division, remember, if you ask yourself now, If I was given a negative 8 over 16 and I was asked to simplify, what would you have done? You would have looked for a number, the highest common factor of 8 and 16. Then you simplify your fraction. So that's basically what you're going to do. So 8 go in negative 8, negative 1 times. Then we continue. And 8 go in 16, 2 times. So we write it there. Then we come and continue. We see that, okay, now I want you to understand. I gave you this example and I switched it just so that you can understand something here. What you should try to do is, because in division, unlike in multiplication where we add the powers, in division we subtract the powers. But you want to make sure that you subtract in such a way that you avoid getting negative powers, because then it means you should simplify it further. And we are going to learn in indices how you can simplify when you have negative powers. But because we have not touched that yet, we want to avoid negative powers. How do we avoid them? We just simply make sure that we take the smaller power in the bigger power always. Now we need to take note of the following, that we don't write the answer in the wrong position. If, remember, this is 1. When there's nothing, there's 1. But you want to make sure that you write your powers down, because in division and multiplication, powers have everything to do with it. You want to come in now, look at the same base and subtract the powers, because they said in division, divide the numbers, subtract the powers of the same base. I'd rather you avoid decimals because it can be kind of confusing. So to avoid that confusion, you simply try to keep it as a fraction. I must always ask myself, where is the smaller power? It's at the denominator. So what does that tell you? It tells you that I must take this 1 out of the top. So because it's smaller, I must go and take it from the top. And when I say 2 minus 1, I'm left with 1, right? So it means there's an A on top. I must not come and write it at the bottom when it was left, because I went to take from the top. So whatever is left at the top. So A is sorted. Then we move on to B. We see that B has the same power, right? So whether we come and subtract at the bottom or we subtract at the top, it's going. So this B, because it's the same power, it goes. However, the C is on top, but there's no C at the bottom. So I'm not going to subtract anything. I'm just going to put it where it is in its original place, and it's on the numerator. So I shouldn't come and write it at the denominator, because then I'm going to be wrong. So in the end, we have a negative AC over 2. We don't write the 1 because they are variables. In algebra, when we have 1A, we write it A. Okay, then we move on to the next fraction. Remember, divide the numbers, subtract the powers of the same base. Now, we want to start with writing down our powers when there's nothing, so that we cannot forget that there's 1. Take note, now we have 16 divided by negative 8, and 16 divided by negative 8 is negative 2, so we write it. So basically we are doing the same thing here. It's like asking ourselves, how many times does negative 8 go in 16? It goes there negative 2 times. It goes in itself 1 time. We move on to the variables. Remember, divide the numbers, subtract the powers of the same base. So we go to the base A. Now remember, I said avoid negative powers. The moment you say 1 minus 2, you get a negative 1. So you don't want to have a negative 1, because then it means you must apply other properties to remove that negative. However, because we have not touched that yet, you want to avoid that. So you ask yourself, where is the bigger power? It's at the bottom, right? So if it's at the bottom, where is the smaller power? It's at the numerator. So that means the smaller power is at the numerator. So you are coming down to the bottom to subtract it from there. So I'm going to come and take this A from the bottom. And the moment I do that, when I come and subtract at the bottom here, it means whatever is left at the bottom, because if I went to the bottom and took out 1, but there was 1 left at the bottom, it should be written at the bottom. The moment I write it next to 2, I'm already going to be wrong, unless I made it negative. However, if I come at the bottom, if I want it positive, I should write it at the bottom, because that's where it was left. Why reposition it? Why write it on top when it's left at the bottom? Then we go to B. We see that B is the same. It has the same power. So it means it's going to go. Whether I subtract from the bottom or top, it's going to go anyway. Then we go to C. There's no C on top, so it's just at the bottom. So when I come and write it down, I write it at the bottom, because that's where it is. Why go write it next to 2 when it's at the bottom? Now, before we get to solve or apply our division properties here I also added some spice and some ingredients to just make it much more interesting. So now we want to remove the brackets before we can apply these properties that we just learned. Remember, divide the numbers, subtract the powers of the same base. However, we have brackets, so we need to remove them first. We still apply the other theory that we learned in the other example, that when we have a power outside is for everything inside, and when we have 1, we just bring it. However, if there was already something there, we should first multiply with what is outside, because it's powers. That you only do when there's only a power outside and not a base and a power. If there was a base and a power, we should still multiply the whole thing, and that will lead to you adding the powers, but that's not what we have. So please don't get confused there. We're just going to say this is going to become 2 to the power 1 times 2, a to the power 2 times 2, b to the power 1 times 2. The power inside times the power outside. Each power that I had inside times the power outside. Okay. Then we are going to do the same at the bottom. We have 2 to the power 1 times 2, a to the power 2 times 2, and b to the power 2 times 2. Now we simplify our powers. So we are going to have 2 to the power of 2, a to the power of 4, b to the power of 2, over 2 to the power of 2, a to the power of 4, b to the power of 4. Then I now work out what do I have there. 2 to the power 2 is something I can get a value to. So that is going to be 4, a to the power of 4, b to the power of 2, over 4, a to the power of 4, b to the power of 4. Now I see now it's simplified, so I can apply my division properties where we're told divide the numbers, subtract the powers of the same base. Dividing 4 with 4 gives me 1. We are dividing the numbers, so the coefficient. So 4 divided by 4 is 1. Then I go, the power 4 and the power 4 will go. You get that? It's like 4 into 4, 1 time. That is on top. Now we come to b. We ask ourselves, is the smallest power of b on top or at the bottom? It's on top, right? The bigger power is at the bottom. Meaning we are going to have something at the bottom, because that's where we are going to subtract, because we are trying to avoid negative powers. So we had b to the power 2 at the top. So it means we are going to say minus 2 and do the same to this one. We are going to take the top one from the bottom, so we can see that there's b to the power 2 that will be left, because 4 minus 2 is 2. So b to the power 2 will be here. Now we see that it was important to write down the 1, because it makes a difference there. Because 1 over b squared is not the same as just b squared. So please don't be tempted not to write it. Unless you're sure that there's a variable next to it, then we would not have written it down. But because it's the only thing that is left, we need to write it down so that we can show it's a fraction and not a whole number. Thank you so much for watching. Don't forget to subscribe, share the video with those that may need it. Until next time, much love.